Last class already we will discuss about what is meant by smart grid, what is the difference between smart grid and conventional power grid, what is the benefits, self-healing, that is important benefit of the smart grid. The fault can be predicted well in advance manner. That property that can be called as self-healing property. The grid which involve intelligent information and communication and control methods which can be incorporated in the conventional grid. That grid can be normally called as smart grid. Intelligent control method and communication technologies which can be involved in the conventional grid. That grid is called as smart grid. The grid having self-healing property, that is an important property. Already we will discuss in the previous classes. Okay. Uh, in this class, various communication methods also we already discussed. Zigbee communication, power line communication, wired communication, wireless communication. Already we were discussed in the last classes. In this class, the continuation of the communication technology and standards we will discuss in this class. Do you hear my voice? Voice கேக்குதா?
Yes, sir. கேக்குது sir.
ஓகே ஓகே. இன்ட்ரப்ஷன் இருந்தா சொல்லுங்க. ஓகே. Self-healing, resiliency, we already discussed, ability to resist failure and rapidly recover from the breakdown. Self-healing, already our ability of the system differentiate automatically between the operating system properly or not. In case abnormal condition take place means it can be able to bring the system to the normal condition. Okay. Communication technologies and standard we already discussed. This already we have our wired communication, wireless communication. Your wireless communication, low infrastructure, ease of connection to difficult, and already have the data flow it can be accomplished through the power line communication or wireless communication. For example, Zigbee communication and 6-LoWPAN communication, Z-Wave and other. Here, the information flow in the grid system. The first flow from sensor and electrical appliances to smart meter. Second is between smart meter and utility data centers. Here, the second information flow from cellular technology or internet can be used. Uh, some limiting factors is available: the smart metering deployment process, the time of deployment, operational cost, availability of technology in the rural, indoor, outdoor area. That is also already you are aware. Zigbee already we will discuss important wireless communication technology. Low power range of operation and data rate can be which is having 16 channel. and 2.4 gigahertz band and 5 megahertz of bandwidth. Transmission range only the less range, 1 meter to 100 meter. Your data transfer rate 250 kb per second. OP PSK communication, OQ PSK modulation can be used, mainly used for smart lighting and energy monitoring, home automation, automatic meter reading. In your mini project as well as main project also, you are using this ZigBee for communication, and also is having some ZigBee smart energy profile, more suitable for communication standard in the US residential network. And here always the ZigBee, which can be integrated with smart meter, that can be communication purpose and also controlling the devices. ZigBee that provide the utility which can be used to send the messages to the house owners. They can reach information of their real time energy consumption. எவ்வளோ எனர்ஜி வந்து நம்ம வந்து டெய்லி வந்து கன்சியூம் பண்றோம் அப்படிங்கிற இன்ஃபர்மேஷன் விச் கேன் பி கம்யூனிகேட்டட் டு த ஹவுஸ் ஓனர்ஸ் ஆர் tenants. Advantage is also already discussed: low cost of deployment, low bandwidth requirement, and operate within the unlicensed spectrum, robustness, mobility, we already aware, and also it can be used at the standardized protocol of IEEE 802.15.4 standard. Okay. Drawback: the low processing capability, memory size is low, and subject to interference with the other appliances. It can share the same transmission system. Interference reduction scheme and avoidance scheme, energy efficient routing protocol should be implemented using your ZigBee. Then wireless mesh, I think you already aware. A mesh network is a flexible network mainly consisting of some group of nodes. The new node can be joined in a group. Each node can be act as the independent router. It is going to form the communication method. A mesh network mainly consisting of group of nodes. The new node can be joined in a particular group. The node can be act as the independent router. The self-healing property which can be enabled the communication signal to find the another route of active nodes, any node to drop out the network. Here some smart devices can be equipped in a radio model. Each of them routes the smart metering data to the nearby smart meter. Okay. Each meter, smart meter can be act as the signal repeater and collected data that can reach the electrical network access point. Collected data which can be transferred to the utility via communication network, that is a private company, that is a communication network which can be allowed to the system. Merits: you already have good coverage that can be provided for urban and suburban areas. We can use the multi-hop routing and improve network performance, balancing the load on the network, and the nature of the mesh network that can allow the meters which can be act as the signal repeaters, and adding more repeaters in the network which can extend the coverage and also the capacity of the network. That is the main advantage of wireless mesh network. Then drawback of wired mesh, like here, network capacity, some padding, and also interferences which can be counted for major challenges for your wireless mesh network. And a third party company which can be going to maintain or manage a network and emitting information which can be passes through every access point. That is another drawback. Some encryption technique also can be used for some data security purposes. That is another drawback. Power line communication, that is already you are using our transmission line. We can transmit the data, transmitting data at a high speed of 2 to 3 megabytes per second from one device to another device. The PLC, power line communication, that is the first choice of communication with the electricity meter due to the direct connection with the meter. Always we are going to connect smart meter with our power line so that communication is very much easier. Here the PLC technology which can be chosen for the data communication between the smart meter and the data concentrator. The data which can be stored or accumulated in a device, that is data concentrator. The communication can be take place between your smart meter and data concentrator. Another one more technology, GPS technology, that can be also used to transferring the data from data concentrator to the utility data center. The data concentrators are normally the low voltage transformer station and process the data from smart meter and load switching devices and also third party device gateway. Advantages, the same advantage. Mainly, it can be very good technology for smart grid application. We are using existing infrastructure. There is no installation cost, and it can be well suited for urban areas in smart grid application. Already covering the areas that can be range of the service territory of the utility company. That is another main advantage. And the drawback, the same drawback, the your power line transmission medium very much harsh and noisy environment and make the channel very difficult to be modeled. That is a drawback. Sensitivity to the disturbance and the quality of signal, that is the main drawback. So that your so much of noise and sensitivity is somewhat lesser, so it can be not suited for data transmission. The low bandwidth characteristic that going to restrict the PLC technology for the application can need the higher amount of bandwidth. Then cellular network communication. The existing cellular network communication, you may aware about the cellular network communication. Now we are using 4G mobile. We can move towards the 5G network. The existing cellular network can be a good option for communicating between the smart meter and the utility between far nodes, and existing infrastructure can avoid the utilities spending some operational cost, additional time for building a dedicated communication infrastructure. Uh, Advantage of your cellular network already exists. The utilities don't have any incur extra cost for building as well as infrastructure requested for smart grid. Already we are having so many communication towers for either BSNL or Airtel or Geo or other network, so that we are not investing any cost for building as well as infrastructure. A huge amount of data will be generated. The cellular network can be going to provide some sufficient bandwidth for communication. The data amount which is very much higher can be generated, can provide sufficient bandwidth for communication. Already we allocate bandwidth for communication. A cellular can be ready to secure the data transmission with strong security control. Already they provide some security. A drawback, the same drawback, cellular network can be shared with the customer market, and sometimes it may result some network congestion. Network problem may be take place. The network performance may decreases due to the congestion in emergency situation, and also these consideration drive the utility to build their own private communication network, and abnormal situation like either windstorm, cellular network, that provider may not provide guarantee service. Some severe lightning, severe rain, severe wind condition, the cellular company does not provide any guarantee to the service. That is the main drawback. We go for DSL, digital subscriber line. Any other merits? So it's demerits for the cellular network. Any merit as well as demerit? I think you are using cellular network. You may aware about the merits and demerits of cellular network. And next one is the digital subscriber line. It is DSL, digital subscriber line. That is a high-speed digital data transmission technology. High-speed transmission data transmission technology, which can use the wires of voice telephone network. Ancient days we are using this type of DSL only. Telephone மூலம் நம்ம வந்து ஃபுல்லாக வந்து கம்யூனிகேஷன் வந்து பண்ணோம் பார்த்துங்க, ஸ்பீடு வந்து ஹையராக வந்து இருக்கும். Digital data transmission technology, wire can be used for this type of transmission. You can see the frequency which can be always greater than 1 megahertz through the ADCL, advanced digital subscriber line, which can be enabled in telephone line. The already existing infrastructure for DSL line, which can reduce the installation cost, and also the many companies choose the DSL technology for the smart grid project. Already on the DSL project install பண்ணிருக்கனால வந்து many companies they are choosing this digital subscriber lines for the smart grid project. Advantages, you already aware, These communication technologies low cost and higher bandwidth data transmission and widespread availability. These are some main advantages for choosing this DSL technology. Cost is somewhat low and higher bandwidth data transmission and widespread availability. All over places can be available. Drawback, mainly the wired DSL based communication system that can require the communication cable which can be installed, and also it can be regularly maintained, and it cannot be implemented in rural areas due to the high cost of installing the fixed infrastructure in the low density area, and reliability and potential downtime of your DSL technology may not be acceptable. And finally, the wire technology such as DSL, digital subscriber line, power line communication, optical fiber are costly and wide area deployment, so that they have the ability to increase the communication capacity, reliability, and also security. Other hand, the wireless technology, it can going to reduce the installation cost. It can provide constrained bandwidth and also security of. We go for the wired technology such as DSL, digital subscriber line, power line communication, optical fiber, which can be more costly, and for wide area deployment, they have the ability to increase the communication capacity. The main advantage, communication capacity can be increased, reliability increased, and security is also get increased. The wireless technology reduce the installation cost. That is very much reduce the installation of the XLR network, and also provide constrained bandwidth and also security options. Okay. Then smart grid communication requirement, we are going to discuss security, some important parameter that is going to require for the smart grid communication. First one is security, secure information storage and also transportation, extremely very important for power utility. Secure information storage and also transportation, which can be extremely important for smart grid communication, and mainly for building purpose and also grid control, and it can try to avoid the cyber attack, and efficient security mechanisms should be developed, and also some sanitization efforts for security of power grid should be made. Otherwise, some hacker made some collapse in your grid, it can affect the entire grid structure. Okay, to avoid the cyber attack, and also efficient security mechanism which can be developed for entire power grid. System reliability, robustness, and availability. That is the second important requirement. System reliability, that becomes one of the most important requirement for power utility. We are giving more priority to the system reliability. Aging power infrastructure and increasing energy consumption, which can be peak demand, create unreliable peak demand that create unreliability issues, aging infrastructure and increasing energy consumption, and also peak demand that create the unreliability issues. And here some embedded intelligent devices, that is IEDs, which can be installed in the entire grid from the substation and also feeder to the consumer resources, that is going to increase the or strengthen the system reliability and robustness. Embedded intelligent devices for the entire power grid, from the substation as well as feeder to the consumer resources, which can be significantly increase or strengthen the system reliability as well as robustness. Here, some communication infrastructure which can be preferred. There is a wireless technology with some constrained bandwidth and also security. Reduced installation cost can be chosen for good choice of large scale smart grid deployment. The wire technology, that is also going to increase the capacity, reliability, and security can be costly. Here we can use the hybrid communication technology with mixed of wired and wireless communication can be used. Here wired technology that is going to increase the capacity, reliability, and security can be costly. Hybrid communication technology with mixed and wired as well as wireless communication, which can be used for smart grid communication. Up to this, any doubt, any clarification? You can use the wireless technology with some constrained bandwidth and also security, reduced installation cost, which can be a good choice for the large scale smart grid deployment. Or we can use both wire and wireless communication. The mixed hybrid communication technology can be used. Then third important requirement, that is scalability. Scalability, a smart grid should be scalable enough to facilitate operation of the power grid. And here, many smart meters and smart sensor nodes, smart data collector, smart concentrator, and renewable resources are combined or integrated to the communication network. There are many smart meter, smart sensor nodes, data concentrator, data collector, and renewable resources like solar, wind, which can be joined to the communication network. Smart grid should be handled the scalability, the integration of advanced web services, and reliable protocol with advanced functionality such as self configuration, and also it can provide some security purpose. Okay, that is importance of scalability. Smart grid standard, smart grid which can involve some various standard for many application techniques, technological solutions can provide for your smart grid development. Here, the key challenge for your smart grid system, the lagging of widely accepted standard. That is the important drawback of your smart grid. The lack of standard that can prevent the integration of advanced application and some smart meter, smart devices, and renewable energy sources then going to limit the interoperability between the smart meter and also smart devices. Okay. The lack of standard can prevent the integration of advanced application and smart meter, smart devices, and renewable energy sources, which can limit the interoperability between the devices, which can be possible. Here, the adoption of interoperability standards for overall system, which is very critical, so that prerequisite for making the smart grid system a reality. And the standardization effort will provide some interoperability between the smart grid devices, robust information security, increased safety for new product system, compact set of protocols, and communication exchange can be happen. The various types of standard and details application. For example, IEC 61850, which is detail can be flexible, future proofing, open standard, communication between the devices, transmission, distribution, and substation automation system, mainly which can be used for substation automation. Here, the IEEE P1901, this is the type of standard, high-speed power and communication. Application can be home multimedia and utility smart grid application. In similar manner, ITU-T G 9955, 9956, some standards are available, which can be used for distribution automation, advanced metering infrastructure. The first IEC 62970, which can be used for energy management. You will clearly refer the table. Similarly, ANSI C128, that is data structure transportation via infrared optical port and this can be advanced metering infrastructure. Similar manner, ISA and SAE, ANSI, HOMEBLOC and HOMEBLOC PHY, HAN, Home Area Network. This standard used for building automation. Open ADR used for price responsive and load control, which can be mainly used for dynamic pricing and demand response. Understand for MBus, advanced meeting infrastructure, Z-Wave, the alternate solution to the ZigBee can handle the interference with this protocol, home area network, and SAE J 2836 supporting use case of plug-in electric vehicle communication can be used for electric vehicle. Another standard that is also used for electric vehicle SAE J 2847 that is also used for electric vehicle. There are some standard. This communication standard which can be used for your smart grid. Okay. Up to this, any doubt, any clarification? Anyone? Balaguru, Durga Salvanis, do you understand the concept?
Yes, sir. Yes, sir.
Kasturi Raja, understand. Any doubt? Any clarification? No doubt. Shall I move to next topic?
Yes, sir.
Okay. Then next one is smart grid drivers. The key market drivers behind the smart grid solution mainly the sustainability and security of supply, aging infrastructure and workforce involved in smart grid, competitive energy prices and security of supply, increased usage of renewable energy resources, and need more energy. These are some smart grid market drivers. The general view for your smart grid market drivers, you can improve efficiency and reliability. Several market drivers which can be suggest for your smart grid can satisfy the increased integration of digital system for increased efficiency of your power system. Here, the restructured environment, the deregulated electricity utility industry that allow the renovation of the electricity market to be used for the power system constraint and seasonal, some daily fluctuation which is available in the demand. Restructure environment means we allow various generators. So many people generate electricity by their own. We can get power supply from that. Consume various solar power plant, various windmill, where various owners are generate their own electricity. That is called as deregulated environment. Diesel power station, either solar power station or wind power station, they generate electricity by own. They sell their electricity to the TNEB or directly to the industry or people. Okay, that is a restructured environment or deregulated electricity industry. Okay, competitive market that is going to increase the shipment of power between the region and which further strain the today aging of grid and it require updated real-time control. Okay, in our area we are having some generator means either thermal or solar power which can be generated means that power which can be distributed to the consumer in the nearby area. Okay, otherwise the generated power which can be integrated or given to the grid. For example, windmill which is available at Kaitar, they can directly given the power to the grid which is available at Panirkulam. 400 kV substation is which is available. Generated power which can be fed with TNEB grid, 400 kV grid. Here can handle the grid congestion and increase the customer participation and reduce the uncertainty of the investment and require the enhancement of the grid capability to handle the demand reliably. We try to increase the power generation means automatically the reliable of power can be given to the consumer. Suppose the number of generators are increased means automatically grid congestion can be take place. The increased customer participation and the reduced uncertainty of the investment, it can require the enhancement of the grid capability to handle the demand reliable manner. Seamlessly, you can integrate the renewable energy system and the distributed energy generation, that is RES. Seamlessly, we are going to integrate renewable energy sources like solar, wind, and also can provide some distributed generation. Suppose the drastic increase in integration of cost competitive distributed generation that is going to also affect the entire power system performance. Stakeholders roles and functions, the important topic here. The legacy of the system, the critical attention must be paid for the identification of the stakeholder, how they function the grid development. Stakeholder means who are all generate electricity by their own, they are all the stakeholder. Who are all consume electricity, they are also the stakeholder. Stakeholder range are policymaker, utilities, researchers, technology providers, vendors, and consumers. They are stakeholders. Policymaker, utilities, researchers, technology provider, and vendors, and also consumers. Here, realization of the smart grid is the complete buy-in and involvement of all type of stakeholder. The primary benefit of this smart grid development, uh, With respect to your stakeholder aspect, mitigation of energy prices, reduced dependence of foreign oils, increased efficiency, reliability of power supply. The primary benefit of smart grid development to the stakeholder mainly focused with mitigation of energy prices, reduced dependence of foreign oil, increased efficiency, and reliability of power supply given to the consumer. This is the pyramid, which is smart grid stakeholder, topmost portion. Then utilities, the installation and implementation of power grid technology. Then next one is policy maker. We are going to establish the standard for operation, monitoring, interoperability. And the next one is technology provider. They can development of smart grid technology for the smart grid enhancement, the research and development that is going to develop the tools and technology for the smart grid, consumer, finally, the consumer input and the participation of the consumer buy-in can be take place. That is a stakeholder and their functions coming. We discuss some two headings. Policymakers. Policymakers are the federal and state regulator responsible for coming out with some guidelines as well as policies for the smart grid. We are going to make some policy for the smart grid with the help of some policymaker, facilitating the need for all the stakeholders. We can consider the example of US in 2007. The former president of US, Bush, signed the Energy Independent Security Act, which can be established in federal policy and the smart grid. 2007 வந்து உங்களுக்கு வந்து President Bush they signed the policy, the Energy and Independent Security Act in US. That is a federal policy regarding your smart grid development. The government of India can move towards the smart grid implemented accelerated power development and reform program, that is APDRP, that can provide the funds to the state LCD board SCB to improve the energy auditing and accounting system. That can also reduces the losses by means of 15%, 15%. The GOI that is going to set up the government of India, set up the smart grid task force, the interministerial group to create the roadmap for the smart grid. Similar development can be happen through the throughout the globe, and pilot projects are running at many locations towards smart grid. It can emphasize the policymakers and creating advanced metering interface for the inclusion of customer as the stakeholders. Then next one is utilities. Here, reinventing the advantage of your SCADA and automation of every component of power sector from the generation to the customers, the deregulation and also restructuring that is going to create the healthy competition and modernization of grid. Restructuring as well as deregulation that is going to provide and modernization of grid can be take place in your system. The huge investment which can be incorporated by implementing advanced metering infrastructure AMI, not only for industrial, commercial and also domestic consumer. Transmission utility that is also going to installing PMU, phase measurement unit for wide area measurement and data concentrator and associated data integration with existing SCADA system. Transmission utilities that mainly involving phasor measurement unit. The phasor measurement unit, we can measure the phase angle along with voltage magnitude. It can be mainly used for wide area measurement and data concentrator, associated data integration with existing SCADA system. Okay, the phasor measurement unit we will discuss in the CO2 can make the transmission system more secure and free from blackout. That is the main advantage of this utility. Researchers and laboratories that we will initiate the smart grid concept by designing, developing tools, some advanced technology for the smart grid implementation. Here, you can make some consortium of academic institutions as working towards development of the smart grid software architecture and the Power System Engineering Research Center, PSERC, Power System Engineering Research Center, You can draw an university capability, address the challenge of power industry. This PSERC is available at US. Under the banner of PSERC, multiple US universities working collaboratively towards about the smart grid development, forward thinking about the future scenarios and the challenges that may arise, facilitating the interchange of idea among the academia, industry, and also government. You can educate the next generation of power industry engineers towards smart grid development, technology providers, vendors, manufacturers that we will discuss in the coming class. Up to this, any doubt, any clarification? Any clarification? Please wait, I want to just take the photograph regarding atoms. Just wait for me. Any other doubt, any clarification regarding smart grid deployment? Now, what about others? Any training program is going on? மற்றவங்கள ஸ்ட்ரென்த் இல்லை 16 பேர் 56 பேர் 16 பேர் இருக்கீங்க 14 only. Please post your attendance. நீங்க மட்டும் போஸ்ட் பண்ணுங்க பார்த்து வந்து சரியா? Tomorrow we will discuss remaining part. Okay. Thank you. Thank you, Anna.
Thank you, sir.
Okay, thank you. நம்ம tutor, please wait. மார்க் ஷீட் ரிசீவ் ஆயிடுச்சோ? மார்க் ஷீட் நீங்க வந்தீங்கன்னா வந்து மார்க் ஷீட் வாங்கிக்கலாம்ப்பா. 5th செமஸ்டர் மார்க் ஷீட் வந்திருக்கு. நீங்க வந்தீங்கன்னா வந்து மார்க் ஷீட் நீங்க வாங்கிக்கலாம். ஓகே, மீட்டிங்